Okay, hello everyone. Welcome to Always Coding. This is our weekly Hacky Hour. Consider these our open office hours, an opportunity for you to ask us questions, and we usually have some demo material for you to get started and start your online training with computer vision. But at any point, definitely ask us questions and we'll stop the presentation and address them. Today's topic is training with YOLO models. So we had a release recently where we're now offering model training support with YOLO models. So we have Todd Gleed today. He's the product manager at alwaysAI, and we're also joined by Lila Milani, and she's going to help us get started. So unfortunately, I'm still having issues with my terminal, but Lila will help us get started with alwaysAI. Also, just before you get started, Lila, if any of you are having trouble with your terminal, please reach out to us. I'll be debugging hopefully today and tomorrow. So we'll have a solution to your issues and help you get started. All right, so with that said, Lila, do you mind sharing how our users can get started with alwaysAI? So if you're new to alwaysAI, follow these steps and get started.
Yeah, definitely. Okay, can you guys all see my my screen? Okay, yeah. Nice. Yes. Yeah, so if you don't know, going to alwaysai.co and show you the home screen. If you haven't been here already, you'll see a login. You can create an account. It's free. Then once you've logged in and gotten your account, you can go to the dashboard. And here you'll see lots of choices. If you click new project, you can create a kind of bare bones object detector and give it a name, create your project. So once you're on this screen, you can see I can download for Mac OS. That's if you've never downloaded the installer before. Mac and Windows have their own installers. And if you go to our docs up here, the first tile will show you how to get started on all operating systems. So Linux, you're going to need to go there for some extra steps. But if you have downloaded the installer, we always recommend just opening the app on desktop. On your Windows, it'll be on your desktop. On Mac, it'll be in your applications folder. And that will check for updates and automatically install any updates after asking you if it's okay. So now that we've created our project and I already have alwaysAI installed, I'm just going to copy this command right here. And you can make a new directory. And there's nothing in here. So when we run this configure with this project ID, it will look for certain files and then download any files that I don't have. I'm just going to be running this on my Mac, so I'm going to choose the local installation. And then you can see there's a couple other commands here, install and start. So we run those. That adds any dependencies, builds our virtual environment, grabs those model files we need. And you can see right now, the regular real-time object detector just comes with MobileNet SSD. And we're going to start it and give it a second to start up. And then you can see that we have to go to localhost 5000. Now it's running. And yeah, that's how you get started. Were there any questions with that? Did I forget anything? Anybody having trouble? You can raise your hand or put it in the Q&A.
Yes, we don't have any questions yet, but I think we're ready to move on to the next piece, which is why you're all here, which is model training with YOLO models. So Todd has created like a little presentation to show you how you can get started with model training on YOLO models and some of the things you might need to get started. So Todd, over to you. Are you on mute?
Hello, sorry about that. A couple technical difficulties with PowerPoint. But yeah, excited to be here. We're excited for YOLO model training. Got one caveat is that this is not released yet. It's going to be released in the next couple of days. There's some bugs, so you're not going to be able to follow along exactly today, but know that pretty soon you're going to be able to train models, and I'm going to be able to demo it and talk about it and get you prepared for when that's released. So let me share my screen. I've got a PowerPoint here, and I'm just going to go over a couple PowerPoint slides and then go into the demo. Can you see this?
Yeah.
See what, and if I guess the technical difficulties when I went into full screen mode, but does that still work?
Yep, it looks good.
Oh, okay, good. So first, I'm just going to talk a little bit about YOLO, why we might want to use it, why we're excited about it, how is it different than the models that we already have in our model training toolkit, and then how is it the same and the process the same? Because really, we kind of integrated it into our existing platforms, into our existing interfaces. So the demo itself is pretty straightforward because there's not a lot of interaction changes, but we can get into that. What you need to get started, and then the demo. So YOLO is one of our most requested additions to our model training toolkit. So you may already know all the stuff that I'm gonna say about YOLO, the reasons why you might be requesting it. So just bear with me. I'll kind of get through this first step. So what is a YOLO model architecture? So this is for real-time object detection. There's a lot of different model architectures, but YOLO is one of the most popular because it can be used in real time, and it's specifically just for object detection, not for image classification or some of the other computer vision functions. Stands for you only look once, which is pretty revolutionary in computer vision, where it just has one forward propagation pass through the neural network, as opposed to going through it multiple times, which is what helps it be so quick in its inferencing time. Something that I want to go over is that there's a lot of versions. So it initially came out in 2015 with version 1, but there have been iterations through that, and we have multiple versions in our catalog. So there's the standard. Tiny is where you just can remove layers. You take a bit of a hit on the accuracy, but it's faster and smaller, obviously. So that's for putting on edge devices, or just the size of the weights and stuff is a little bit smaller. And right now they have come out with up to version 5. So V2, V3, V4. There was a kind of a quick update from version 4 to version 5. So the true, if version 5 is a big improvement, is kind of remains to be seen. But what they're doing in those incremental improvements is changing the layers, kind of improving specific layers on there, and trying to address gaps that they have in previous versions. So in the first version, YOLO is kind of had a hard time with small objects, but just based on the way they do their inferencing in kind of a grid and one pass through. And so in newer versions, they have started to address that. So let me just kind of show you in our model catalog all the different versions of YOLO that we have. And this is not ones that you train on, but ones that are pre-trained on, like the COCO data set or something. So if you just go to alwaysAI.co, our model catalog, and search for YOLO, you could see that we've got 18 results. And there's a wide variety here. And so these top ones are device specific YOLOs, and these are for things like the Jetson Xavier, the Nano, and we have optimized these models. Steve Grissett has taken the time to take YOLO, and it says the version here, optimize it for these specific devices, and just really get that bump in speed that you're looking for when you have, you know, a Nano or Xavier NX and stuff. So we've got V3, we've got V4s, and this number here is the kind of the size of the model, which is the image size that you put in. And then we have standard non-device specific tiny. This is, again, it's a little faster, not as accurate, but you'll find it's still pretty accurate, and we kind of can go over some of those numbers. V3, V4, tiny and not tiny, and this is just kind of an example of what we have in the catalog. What we are offering initially for training is training YOLO V3. And so that's, and I'll get into a little bit later, but we're quickly able to add versions, you know, either as they come out or as we do this. So that's a little background. Here's kind of examples. This is taken right from the source. It's this site is where you can get, you know, the YOLO models to run, and this is kind of comparison versus other object detection models that are out there. Over here, so this is, you know, why would you want to use it? Like I said before, it's fast and it's accurate. So as far as speed, you know, they did this clever little scaling where the YOLO models is off the scale to the left because it's so fast inferencing. You can see 50 milliseconds and YOLO's here compared to, you know, RetinaNet, a couple different versions. They've got some SSDs up here, and you can see the speed and how YOLO, this is the V3, just kind of is lower than most everything. Even the biggest version of the model down here still maintains its speed, and then it gets into mean average precision as well, where this mean average precision is comparable, if not higher, while still having the fastest inference time. And then getting into accuracy, this is comparing it to, again, you know, some retina models, some SSDs, and you could see that the mean average precision is higher than a lot, while getting a lower. Sorry, this keeps on switching. But yeah, we could do some comparison here, and you could see, you know, the comparison between tiny and regular, where you do lose some of the precision, but the frames per second goes up significantly. So depending on what your use case is, if you're okay with a little less accuracy, but you want that speed in that real time, you can compare those. And I didn't have time to do it, or we're going to planning another Hacky Hour where I'll do real world situations, training models, same data sets with all the versions of models that we offer to get some real time comparison. So what are the differences? Some things that I mentioned before is the architecture. You know, you only look once. The architecture is different. The speed and accuracy, and that's different than the two other models that we offer right now. Another thing is the training time. So the way that the validation is done should speed up that portion of it, but the size may slow it down. So in some cases, you may see a speed up of training time, or you may see a slowdown of training time compared to whether you're comparing it to the MobileNet SSD, it might be a little slower, but compared to the faster RCNN model we offer, it's probably a little faster than that. And then the output of training is going to be different. The TensorFlow MobileNet SSD that we have right now is kind of PB files, and then the YOLO, the model files, are a set of weights and config files. But the big thing I want to highlight about the difference between what we currently have and the YOLO is the framework that we implemented it in. So previously we're using TensorFlow as a framework, and this we've implemented in PyTorch. So some of the changes that you'll notice when you're training is in the loss calculations. So there's not necessarily a one-to-one ratio of the loss, comparing the loss of a MobileNet model trained with us with the YOLO model. We've got some different configurations. That's kind of back-end stuff that right now we're keeping from you, so you don't have to worry about it. But what implementing in PyTorch is going to let us do is come out with future enhancements to the toolkit a lot easier and a lot faster. So we've already got YOLO v4 in the pipeline, and the way that we implement that with PyTorch is going to make it easier to expose advanced configurations to the users, and then also expose and display the output of model training. So that mean average precision and recall and stuff like that, we're going to be able to kind of standardize that through PyTorch and display that to you. Last thing,
actually,
sure. Yep.
Let's pause for a second and address some of these questions we have.
Great.
So the first one is, can we customize our labels? And I just want to announce to everyone that Steve Bottos has answered this question, where you can, and you'll need to create a data set with your annotations, and you can select that to train on it, and it will automatically detect the labels and structure the model accordingly. But the next two questions haven't been answered. So it's, I've worked with YOLO 3. Could you compare this version with that of 4 and 5? So how would you say versions 4 and 5 compare?
Yeah, so I may need Steve to jump in. I mean, like I said, so what I just know from reading the papers, I haven't trained v4 or v5, but I know that they are optimizing the layers to address gaps, specifically like being able to detect small objects in things is some of the stuff that they're working on, and improving speed while not giving up accuracy. Steve, do you have anything to add on
yeah,
the differences?
I think my audio is working now, is it?
Yep, can hear you.
Okay, cool. Yeah, sure. That was I can build off that. That's a good answer though. Basically, what the difference between v4 and v3 is yeah, architectural, like Todd said, and you're gonna see some accuracy boosts as well as speed boosts between the two. YOLO v4 being the superior one by about, I mean, the figures that I've seen are like 3% or so in precision and recall, and a little bit faster, nothing like groundbreaking. V5, however, there's a little bit of controversy about V5. Really what V5 is kind of a re-implementation of YOLO v4 that's not necessarily canonical. Like the people that developed YOLO v4 are the same people that have developed v3, v2, and the first one. The people that developed v5 is a company called Ultralytics, and they're not really associated with the guys that developed the original YOLO. What they did was essentially take the darknet implementation of YOLO's backbone and kind of convert that into PyTorch and make a few tweaks here and there that make it easier to deploy for people that just want to get a quick deployment out. But it actually performs worse than YOLO v4 because of the loss of that darknet backbone, which is written in C, converted into PyTorch. So you'll get, it's a little bit worse on inference time and it's worse on accuracy. So if you really want to squeeze out the best of the best, you're going to use YOLO v4. And of course, the issues with deployment are handled by us already, so you don't have to worry about that. But if I were someone that just wants to know which one of the 5 or 4, depending on if you consider the unofficial release one that actually matters. If I were someone that just wants the best of all those, YOLO v4 is the way to go. YOLO v3 is slightly behind, but really not by much, and it honestly performs, satisfactory in any scenario that I've used it in. So I hope that clears it up. If there's any more details that you're interested in, feel free to just drop a line in the chat and I'll see what I can do.
Yeah, and Steve has also added that alwaysAI currently does not support YOLO v5. So that's also something to keep in mind.
Yes, v5 is unsupported. v4 is in the pipeline.
Sweet. And then is YOLO v4 by Alexei AB or another author? And I think you touched on it a little bit, Steve, but maybe
Yeah, sure. That he is someone that's actually associated with the guys that had created the original YOLO. So it's not the Redding guy that you might be familiar with that did all the other models, but he's associated with him. So it is like technically an official YOLO model. But yeah, it's by YOLO v4 is by that Alexei Bachovsky guy, if I'm pronouncing that right.
all good. Okay, so yeah, there's no more questions. So Todd, you can continue.
Okay, thanks, Steve. That was really good. And so this kind of gets to the first question about can you assign your own labels? So what is the same is you need a data set. So that is taking the images. I could show after I mentioned these other two things, I can quickly cover data sets. I've covered different aspects of collecting data, annotating data in past Hacky Hours. So I'm not going to spend too much time on that, but you collect and annotate your data the same way for previous versions, and then up and use it in our interfaces the same way. And YOLO arguably is closer to the MobileNet model that we offer now than the faster RCNN, because it's more edge ready, and you're going to get different performance based on the device you use it on, whether it's a Pi or one of the NVIDIA devices. And then the other thing that you need to get started using the Model Training Toolkit is an alwaysAI account. And right now for model training, you do need a paid account to use. But what we are exploring is ways of people who have been training. We don't want to cut you off from your training. So if that is something that you're doing where you've been using us, reach out and we can talk to you more about that. So let me just get into the demo now and quickly go over data sets. So I'm just going to give an example of a data set that I have. So here's data sets that I've made for different projects that we worked on. Some of you may remember doing a package detector, and what the data set is going to look like is a folder of annotations and a folder of images zipped up into a zip file. The images are JPEGs, PNGs that you've collected, and then through an annotation tool of your choice, if you are using us, we have CVAT integrated, but you then annotate each one in the Pascal VOC format, which is an XML file, which contains the image that is associated with it, and then the bounding box here. So again, there's more detail in other videos, but that's what you need to get started. And this is what I'm going to demo training. So let's see. Any questions on data sets? So what I'm going to demo today is training a YOLO model on using our Jupyter notebooks. So Jupyter notebooks is really our kind of testing ground. This is where you're going to have features that we are kind of proving the value of. We want your feedback in, and I'll give you some examples of that as we go. But this is really where our latest and our greatest is, and then we bring these out to the desktop and we bring them out to the CLI accordingly. So we get there with AI dataset train and then -- Jupyter. And what this will do is start a Jupyter notebook. It'll give kind of a default model name. You don't have to worry about that. You will be able to change it, and just be patient as this loads up. So you may see what it just said, where it cannot be found, or localhost. It'll get there to automatically open the URL, starting a server at this port on your machine, and then open up the notebook. And then the way to start it, there's multiple ways to run a cell, but just running this first cell will bring up the interface here. And so here you could tell I've got some advanced things set up, but I'm going to go over what you need to do and show you things that are unique to the notebook. This is an S3 bucket that I have connected, and this is connecting this to a AWS S3. So if you want to have your own S3, connect it. That's kind of something that we're not really advertising. It's kind of in beta stage, but we are exploring kind of data sets in the cloud. And then here with the data sets, we've got some features here that we don't yet have on the desktop. So I'll show you those. These are past data sets that I've trained on. Masked YOLO. This is one on AWS. But these are my local data sets. And then I can upload a new one, selecting a file. This is where I'll go kind of right back to where I was. Oops. To my data sets. I'm going to go mask, no mask, and I'm going to get maybe this merge data sets. I've got a couple different versions. I was playing with augmenting data, but just choose again, a zip file that's contains a annotations folder and an images folder. I can name the data set, and that way next time I come in here, I can choose it from the drop down. You could choose to resize it. That's just going to go through and make each picture uniform. Kind of a little pre-processing that will save you time in the future, because as you see, the size is going to change based on the model that you're training. You could set the train validation fraction. Default is 80% training, keep 20% back for validation. And this is important to set and keep for the data set. So if you're continuing from something, you have the same images used for training and validation, so that you're not running validation on images that you previously trained on. And then you can save it locally. And again, I've got S3. So I'll create that, and the results of creating a data set or loading a data set is another feature that we have implemented in the notebook that we're looking to bring out into the other interfaces, and that is kind of giving you an overview of the contents of that data set. So
Scott, there's actually a really good question here in the chat. If the training failed, is it possible to restart training at the last checkpoint, since the version is not available for the new model? And that question is for both the CLI and the notebook GUI.
Right. If there's an error in your training, we do save checkpoints throughout the training process. So if you manually stop it at a certain time, like in the desktop, then we close it up nicely and allow you, kind of create a version and call it. But if it gets interrupted, or if something happens, we are saving checkpoints throughout that process that we can then use to create a version. Right now, it's a little more manual, and someone like myself or Lila, Steve can help you do that. If that has occurred, we kind of go into where we store the model as it's being trained, where we're writing it to your computer, and can create a usable package to then bring back into the interface and use as a continue from version. But so yes, we can restore from the last created checkpoint. It's just a little manual right now. So if that has happened to you, we can you won't lose all your training.
Yeah, so yeah,
But
if it happened to you, feel free to reach out to us and we'll be happy to help you out.
Right, but
Okay, great. And he said he needs help on that. So cool. Like Philip, you and I have a call scheduled, so we can touch base on that. All right. Todd, you can continue.
Sure. So this is something that, so for all our interfaces, when you upload a data set, we parse out the labels. But here in the notebook right now, we go a little deeper. We get the dimensions of the images. So these are all uniform. All 1244 of the images have the same dimensions. But if you had multiple dimensions, it would list them out here so that you could see if how big they are. If you wanted, of course, if you use the resize feature, they're all going to be the same dimension. But then we also have the breakdown. So of the 1244 annotations, and there can be multiple per image, as you can see. This is kind of the breakdown. There's over 2,000 total annotations on there, and 1,700 of them are mask and 410 are no mask. So this is where you can kind of get an idea of how balanced your data set is. I've talked in different sessions that you kind of want all your labels to be pretty balanced, just to help your model perform. But this kind of summary and validation of your data set is a feature right now that's on the notebook, and we're looking to bring out. The other thing that we're playing with and getting right now is the model. So this is where you've chosen your data set, and this is where you choose the model that you want to train it on. So we've got the MobileNet SSD as default. That's kind of our standard edge device ready model. And then we've got the faster RCNN, which is takes a little longer to train and a little longer to inference, but it's more accurate. And then this is the new YOLO V3, and this is what we're going to choose. But I just want to talk a little bit about this feature, and kind of want to get your feedback. So the way that you continue from a version now is on the CLI, putting continue from version flag. In the desktop, we've got a drop down saying continue, a checkbox, continue from version. Here, we're kind of showing you all of your past models that you've trained. So this is, testing that I was doing last night, mass detector that I did previously using. And so when you're after choosing a data set, you can choose the model that you want to use. And these are our standard, and then these are your personal models. And this is how you select continue from. So this is a new way of interacting with the continue from that we think is, kind of a good way to make sure that you're continuing from a past version. So I'm going to select YOLO V3. So if I were to select like an old model, then the available versions of that model are available down in this drop it, which is pretty good. So this is the default name. I'm going to name it something here. Just going to show you. Hacky YOLO. Input size. This is the images. The size of the images as they're processed in the model. So each model has a default. You saw in the model catalog that YOLO is 416. I'm not exactly sure what our default is. Is that what it is, Steve? 416 by 416?
I believe we default to 320.
320. Yep. It's but we do offer, different sizes. The larger image size you go, which I guess I could pull back up. I'm not going to do it, but you saw in the PowerPoint that if you do it with larger image sizes, it's going to take a little longer to inference, a little longer to train, and you'll get a little more accuracy. So again, it's just that trade-off depending on your project, what you want to do. Unless you really know or have a reason to change, we recommend leaving the model default, and that's going to change based on MobileNet and based on YOLO. This is pretty similar to before. The number of epochs, again, that's just running through every image in your data set one time. And then batch size is how many images you're going to process before going to the next step. This is plotting the loss. You'll see the graph come up here. You can plot 1 step, 2 steps. It's how fine-grained you want to be when you have when you're training for a number of epochs and have a large data set and you've got thousands of steps. There's really no need to plot like every steps. You can do every 10, every 100. And then the validation of epochs, usually you want to see that after each epoch, and that's really kind of the information giving you the feedback. And what's great about the PyTorch implementation is it's a lot faster to do that validation, where in TensorFlow kind of needed to shut down training. If you were running our model training in the CLI or in another version, you can kind of see it hang and take some of the steps are pretty consistent, and then you get a big long step where it was running the validation, which with the PyTorch backend, that's not necessarily the case, and we're pretty excited about that. And this early stopping rounds is something that we've had in beta for a while. We haven't advertised it too much, but it's a way to automatically shut down training based on the performance, where if the model is not improving over a certain number of rounds, it'll stop automatically, because at that point you're not getting any gain for training further. Begin training, and this is again just a little patient. It's gonna process the data set, put it in the format that PyTorch wants to be, go through every image, every annotation, and really set it up to train. Are there any questions? We'll wait for this to process and begin.
No, we don't have any yet.
Okay. Yeah, so what this is going to do, it's going to bring up the graph that's going to plot loss for each step. You'll get the kind of total number of steps. So if you could do just quick mental well, I guess we don't have to do mental calculations now, but with 1,200 images at batch size 2, an epoch will be 600 steps, and since we're doing 2 epochs, it'll be 1,200 steps, and that's what it shows down here. I mentioned before the loss and how it can be calculated different with each model, and so I'll show that next time when I do kind of a comparison. But you'll see the loss here starts at about 20, kind of gets a gradual rundown improvement of loss over time. Where if we're starting something with the TensorFlow, MobileNet tends to start at about 50% and drops down pretty significantly. And that's just a product of the back end and how it's calculated and how the models work. So this is going to take a bit of time, so I'm not really going to, I guess we don't have to sit here and watch it go. But I did train a model last night, so we can run that and just see how it works. It was the same data set, so mask, no mask, and I ran it for about, I think I ran it for 10 epochs at a batch size of 4. I should have screenshotted the results of it, but I think it took about maybe 3 hours, and I mean, this is kind of silly, but the line, just kind of, it got a little better and it went down kind of like this. I did test it out before this, and it's not the best, but we'll show and we'll get idea of the inference time, and I'm going to show you how that works. So this is what you see. So maybe I'll shut this down just to, my computer's doing a lot of stuff. I don't necessarily want to run it while running training, but this is an example of running a model. So when you shut down the notebook, you're going to get something that looks like an error, but that's standard. Don't be alarmed that it's saying connect. No problem. And then same as our other models, there's 2 ways of using your model. Like, once you're done, you can do AI model publish, and then put your username and the model name, and that will push it up to your alwaysAI personal models where you have access to it from anywhere. And the other way of doing it is here in the app. So I'm in a object detector app that I created just to demo this. And that would be AI app models add, and then that would be putting again the name of the model here, and then doing local version and putting whatever versions they have. So it's, the first one's gonna be 0.1 or 0.2. The one that I'm training is, or the one that I'm showing is version 2. So let's see if this is still.
Also, Todd, how did you decide to make 320 by 320 the default?
So Steve can probably speak to that, but I think it's just a happy medium of speed of inferencing and accuracy. But yeah, that was a Steve decision.
Yeah. Basically the reason for that is that's about as small as people typically go with YOLO. That's like the smallest image size. You can go lower as long as it's a multiple of 32, you'll be fine. But I mean, people typically don't go lower than 320 by 320. The reason we stuck with the lowest as the default is because most of the people, you guys that are using our platform, are likely trying to get this running on an edge device. And when you're trying to run on an edge device, you probably don't want to add any additional overhead unless you manually override it to do so. So that's why.
Right, and for our MobileNet SSD, we started out pretty small with that one as well, 300 by 300, and added a couple bigger sizes, and even you can go as big as you want. And what we find is that the gains for going bigger weren't significant enough to for most of our projects to justify going bigger. You know, we had a lot of success with 300 by 300. You know, impressed with the accuracy, and so yeah, kind of wanted to continue that. So I loaded this in there. This is the test YOLO that I trained last night. Tells you what.
And following up on the 320 question, it can also be divided by 16, right? Steve's asking you that.
Yeah, I thought it was 16.
Sorry, what was that?
It's divisible by 16.
I believe if it's divisible by, I think it's 32, but it could be 16. I'll double check that.
So this is it running. As you can see, it's I have a couple models made with this data set, and I think this isn't. I have with the augmented data set, and it works a little better than this. Usually, you know, it's getting my face and saying no mask. Let's see if we can get to do it. Not really, but you can see the inference time. So this model needs a little more training, but you can see the inference time where you know, kind of in the tenth of a second, and that's probably what we're going to see. Usually when we train this is that's what we see consistently through the models. So this is going to change based on the device you run it on, the different accelerators that you have, but this is about the speed that it's running on my computer. So that's it. You can't really get it. So this is where I just go back and do continue from and run it for, you know, about 4 times as much to get it, but we can see it going. So that's it. That's a demo. Any questions?
So actually, Andre got back about the 16 question. It says by 32. So, okay.
32 is the answer. Is that what you said?
Yeah.
I believe it's the batch size that needs to be divisible by 16 or something like that. There's some 16 is somewhere in there, but the image I'm sure is 32.
Nice.
Okay, great. Well, thank you so much for the presentation, Todd. So yeah, if you're interested in trying out model training and like follow along with the exact tutorial that Todd provided, I will be sending an email in a little while, just offering like a free 14-day trial of Basic, so everyone can give that a go. All you need to do is fill out a survey and let us know what you think about alwaysAI, and just give us your honest feedback, and then we'll initiate that 14-day trial for you to try model training and try training on YOLO models. So if there's no other questions, I believe it's okay. Oh, yeah, so Deepika, I'll send a recording of this. If you're interested in seeing this Hacky Hour or other Hacky Hours in the past, you can just type in Hacky Hours on YouTube, and we have a playlist that you can take a look at. So if you want to access it immediately and rewatch it, that'll be available to you that way as well. But sure, Deepika, I can definitely send you a recording. All right, so if there's no other questions, thank you so much, Todd, for joining, and Steve for offering great insights. And we'll see you guys next week. Take care.